All right, we are going to talk about vertex form. So we're going to start by converting vertex form to general form. So to do this, you just need to follow order of operations, which says we need to take care of this exponent first. So I have 3, x minus 4 squared is really x minus 4 times x minus 4. My plus 1 is still on the end. When I multiply this out, I'll leave the 3. I'll have x times x is x squared minus 4x gives me minus 8x. Negative 4 times negative 4 gives me plus 16. Now I can distribute the 3, so I have 3x squared minus 24x. 3 times 16 is a 48. Still have that plus 1 on the end. I can combine my like terms. I end up with 3x squared minus 24x plus 49. So I have my general form equation. Every time I convert from vertex form to general form, I will have a perfect square that I have to multiply out. After you multiply some binomials that are squared, you start to notice a pattern. If I have x plus 3 squared, that's really x plus 3 times x plus 3. I get x squared plus 3x is 6x. 3 times 3 is 9. If I do x minus 5 squared, well, that's x minus 5 times x minus 5. I have x squared minus a 5x is minus 10x in the middle. Negative 5 times negative 5 is a plus 25 on the end. Every time this term is doubled in the middle and squared on the end. The negative 5 is doubled to a negative 10 in the middle, and it's squared to a positive 25 on the end. We can use this pattern to help us create our own perfect squares so that we can go backwards in this and take something that's in general form and convert it to vertex form. So if we want to go the other direction, we want to start with something in general form. We'll start with one where a is 1 because those are easier to deal with. So if I have this general form equation, I need to create my own perfect square. So I'm going to look at the x squared and the x term and ignore this 3 on the end. I know that that's not the number I want, so I'm going to leave a blank so that I can put in the number I do want and just slide that 3 over out of the way. Now I need to think about what squared will end up giving me an 8x in the middle. Well, if I think about my pattern from before, I know that whatever number is here ends up being doubled in the middle right there. So I must have this factor to x plus 4 squared. If I want these 3 terms to factor to x plus 4 squared, then in this blank right here, I need a 16. 4 times 4 is 16. But we all know we can't just add a 16 whenever we feel like it. This is an equation. It has to stay equal. So if I've added a 16 here, I need to balance that out and keep my equation equal by subtracting a 16 on the end. Then I can have these 3 terms factor to x plus 4 squared. These 2 numbers on the end will combine to give me a negative 13 on the end. I have created my own perfect square with a constant term left over. This is vertex form. I can now tell that my vertex must be at negative 4, negative 13. I'll do another one quickly where a is 1 again. If I start with this equation, I want to always take whatever number I'm given and slide it over out of my way. I don't want to look at the 8. I want to just think about the x squared and the x term. If I have x squared minus 12x, I know that this is going to have to factor to something to make a perfect square. I want a perfect square. If this is a minus 12, then this must have been a minus 6, so that when it doubles, I get to my minus 12. If this is a negative 6, then in this blank, I sure wish that I had negative 6 squared, which is 36. I can't just add a 36 because I feel like it, so I'm going to subtract 1 on the end. Now I can combine my terms out here, and I get minus 28. My vertex form equation is right here. I can see that the vertex is at 6, negative 28. If a doesn't equal 1, there's a bit more work involved. Suppose I have this equation. In order to complete the square here, I also need this 2 to be out of my way. I just want to have x squared plus something x. So the first thing I need to do is factor this 2 out of both the x squared and the x term. Just like before, I'm going to ignore the number on the end though. So first I will move that over out of my way. Something will go here. This minus 1 is over on the end. Now I'm going to factor this area that is my perfect square. So I'm going to take out a 2, which will leave an x squared plus a 6x in the middle, plus I'm not sure right there. The minus 1 is still on the end. Now I want to factor this part into a perfect square. The 2 just comes down. If this is a 6, I know that I must have a 3 right here, so that when I double this 3, I get a 6. This is a perfect square. So if this is a 3, 3 squared means I must have had a 9 in this blank. But there's an extra step now. I didn't really add 9 because remember I was factoring this spot as well. So if I go up one more step, what I really had here was 2 times 9. This was an 18 that I really added. So on the end, I need to subtract an 18. Even though it got factored here, I'm really dealing with an 18. If I combine those two terms, I have a minus 19 on the end of my equation. So now I can see that my vertex is at negative 3, negative 19. We'll do one more, where a is something other than 1. If I want to take this and convert it to vertex form, first thing I need to do is move the number on the end over out of my way. Now I'm going to factor. I have a negative 5 out front, so if I factor that out, I'll be left with an x squared. 10 divided by negative 5 will leave me a negative 2x in the middle. My 4 is still on the end. So I can bring down the negative 5. My squared term, if this is a minus 2x, I know this has to be a minus 1. So that when I double the minus 1, I get a minus 2. Negative 1 times negative 1 gives me a positive 1. So that's what I want in the blank. But remember, it's not just a plain 1. It's a negative 5 times 1. This is really a negative 5. If I have a negative 5 here that I need to balance out, I need to add a positive 5 on the end. So that when I combine these terms, I end up with a plus 9 for this one. My vertex is at 1, 9 for this equation.